Hello, good day! Ito nga pala ang inyong Sir Jello at mayroon ako ulit ituturo sa inyo na math video topics. Pero bago yan, huwag niyo munang kalimutang mag-subscribe sa aking YouTube channel na Sir Jello para maging updated kayo sa lahat ng videos na i-upload ko. Okay, so good day sa inyong lahat. So welcome to our another video tutorial on quadrilaterals. This time we're going to discuss all about kites. So let's proceed. So kite is a quadrilateral with two pairs of adjacent and congruent sides. So if you can see here, this kite, it has two pairs of that definition. Let's use the green one. So the first pair of adjacent congruent side will be this side and then this side. So these are adjacent and congruent sides, and then the other pair will be this side and then this side. Okay, so we have side BC congruent to side CD. Okay, side BC congruent to side CD, and then side BA congruent to side DA. Okay, and then rhombus is a special kind of kite. Okay, so that is an example of a kite. Now we have here 5 theorems or theorems related to kites. So number 1, in a kite the diagonals are perpendicular. So when you say perpendicular, it will form a 90-degree angle for the given diagonals. So in this case, the diagonals are line segment BD is perpendicular to line segment CA. Okay, so the perpendicularity shows here at some point. Okay, next, number 2, in a kite there is exactly one pair of opposite angles that are congruent. So if we're going to look at this kite ABCD, the opposite angles that are congruent will be angle B and angle D. So angle B is congruent to angle D. That is the pair we are referring to of opposite angles that are congruent. Okay. Next, number 3, the longer diagonal, which is this diagonal, is the perpendicular bisector of the short diagonal. So meaning CA, line segment CA, is the perpendicular bisector of line segment BD, meaning the measure of B to the point of intersection of these two diagonals, let's say this is E. So line segment BE is equal to DE because of the perpendicular bisector of the longer diagonal. So we can say here that BE is equal to DE because of the perpendicular bisector. Okay, next, number 4, there is exactly one diagonal bisects a pair of opposite angles. So in this case, we have, let's say, angle A. Okay? So, this angle bisects a pair of opposite angles. So, what are those? Can be BAC, and then DAC. Okay. So, because it bisects these opposite angles into two. And then the other pair will be, or the other angle rather, will be angle C. That will be angle BCA and angle DCA. Okay. So that is the role of the word bisect. It divides this angle into two angles or congruent angles. Okay. So we can jot it down. And so you have angle, first for angle A, you have angle BAC congruent to angle DAC because of angle A. And then the other one will be angle BCA congruent to angle DCA. Okay. Next, number 5. The area of kite is half the product of its diagonals. So we can actually solve for the area of this kite given the diagonals. So the formula will be A, or the area of the kite, is equal to 1/2 the product of two diagonals. So later on we're going to have an example for that. Okay. So let's proceed now with our activity that we can apply the different theorems regarding kite. So let's say you are given the measure of angle B, which is 100 degrees. Find the measure of angle D. So based on the theorem, we know that here B and D are opposite angles, and this is the only pair in a kite that the opposite angles are congruent. So if angle B is 100, so the measure of angle D is also 100 degrees, since they are opposite angles of the kite and they are congruent. Okay. Next, let us now try to solve for the area of this kite given the measure of segment BD, which is 8 centimeters, and CA, which is 12 centimeters. So we know that the area for kite is the area is equal to 1/2 times the product of the two diagonals. So we have 1/2, 8 multiplied by 12, we have 1/2, 8 times 12 is 96, then 1/2 of 96 is 48, so that is 48 square centimeters. So that is the area of the kite. Okay, next, we have the measure of angle C, which is 110 degrees. Find the measure of angle BCA and DCA. So we know that in a kite, the opposite angles bisect the angles, in this case, into two congruent measures. So if the measure of angles is 110 degrees, so you just divide 110 into 2, since this angle BCA is congruent to this angle DCA. So since the given is 110 degrees, the measure of angle BCA, we just divide 110 by 2, so that is 55 degrees. That is also the same with the measure of angle DCA, since the opposite angles bisect in a kite. Next. So we're going to identify the parts that are related or congruent to the given side or angle. So we just fill in the blanks here. So let's say number 1, BC is congruent to which side? Of course, the adjacent of this side, which is this side, so that is CD. Okay. Next, for side BA, of course, the other adjacent side, which is DA. Angle B is congruent to this angle, so that is angle D. Number 4, angle BCA, so this angle is congruent to angle, this angle, so that is DCA. Angle DCA. Number 5, we have angle BAC. BAC is congruent to angle DAC. And then BE, segment BE is congruent to segment DE. Okay, so we already have all the answers. So as long as we are very observant with the theorems or the illustration of a kite, we can, or you can, answer the blanks very easily. Okay, so thank you for watching, and I hope you learned something about kite and its different theorems. With that, have a good day.